Hello, fellow splicers. Ever wondered how we use machine learning with Splice Machine? Let's see how.
Spark provides a stack of libraries currently, and new ones are being developed. Some of its libraries are for SQL and data frame, machine learning, MLlib, graphics, and Spark streaming. In this tutorial, we will learn how to interface with machine learning library within Splice Machine. Spark's machine learning library provides APIs for some basic statistics like summary statistics, correlations, random data generation, as well as several common learning algorithms and utilities, including collaborative filtering, classification, etc. The best way to learn is by taking a use case scenario and implementing it. So here I have taken the movie lens dataset. This is data of rating of a movie made by a user. So the main data is for user, the user information like the user ID and the demographics like age, zip code, occupation, etc. Then the next one is movies information itself, and then the rating information. So in the rating information, you have user and the movie, what rating was provided for that movie by that user. So first let's get this data into the database. So here I have Splice database. I have created movie lens schema and the tables for that data. So I have the user demographics table for users, movies table for movies information, and user rating table for the rating information, and some other supporting tables. I have already loaded some data also into these tables. I have like 950 users, 1700 movies, and around 10,000 ratings. Well, now I have data. What do I do with it? So the first thing we want to do is understand the data itself. So, get the features of the data. So we build a feature report, which will be basically giving you some statistics on the data so that you can understand how good your data is. For this, we will use MLib's summary statistics API. Once we understand the data, then we will go ahead and try to build a model for making recommendations. For that, we will use the user rating information that we already have, learn from it, and then make predictions for the missing ratings. So we are going to use collaborative filtering here, and the algorithm will be alternative least square ALS algorithm. So we are going to build the model, evaluate our model, and then we will save the model. So next we will use the saved model to make movie recommendations for a given user. Now let's look at the implementation details. I have created stored procedures for these three features we want to build. So I have created a stored procedure for data features. I have created a stored procedure to build the model, and then a stored procedure to make recommendations. You can also create them as Spark applications. In this tutorial, we will focus on stored procedures. So let's look at those stored procedures. So I have a kind of continuous feature report, which takes in a table name and then provides statistics for the columns in that table. So it is giving you, for example, in this case, you have age, and then it provides you the minimum value, the maximum value for age in the data. Then you have others like standard deviation and mean. The next stored procedure is to build the movie recommender. So this one is going to go use the user rating data and then build a model using the ALS algorithm. Once we have the model, then I have this stored procedure which I can use to make, say, prediction for the, say, user 2, and then I want to get 5 recommendations. So I have the stored procedure. When I run, it gives me 5 recommendations for that user. So now let's look at how to implement this. Splice's stored procedures are Java based. What that means is the stored procedure is implemented as Java classes and methods. So to further understand the implementation of stored procedure, you may want to look at Splice's tutorials for creating stored procedures. So the first step would be to create the Java method to implement the stored procedure. So let's start looking at that. So let's start with feature report. So here is the feature report class, and I have a public static method continuous feature report. So this is the method that gets invoked when we make that call, stored procedure call in the database. So let's see what we do in this stored procedure or in this class, which corresponds to the stored procedure. So we saw that the input for the stored procedure was a table name for which we want to get the feature report. Now we need to, first thing we have to do is get the columns for which we have to create the statistics. So the information about the columns for a given table are saved in the data feature table in the movie lens schema. So we will first read that, query that table to get the list of columns for the table name specified, which in the example I showed you was user demographics. So basically what I'm trying to do is for user demographics table, look at the data feature to get the list of columns for which you will need to get the column statistics. This is standard here. You are using the prepared statement Java, and then execute the prepared statement and get the result set using JDBC. So once we have the columns, we are just gathering the column information. So we did find some columns for which we need to get stats. So now we have the columns. Next step is to get the data in those columns. So again, we will use the JDBC connection and the prepared statements to fetch the data from the table for those columns we have identified. Now we see that we have a result set RS2 with which contains the data of the columns. Since we have to prepare this for mlib APIs, so we have to convert this record set to a Java RDD. So we are going to call this method which would take a result set and return a Java RDD. Now let's look at that one. In the result set RDD, basically we are using Spark mlib utils. This is provided by Splice machine and provides some useful util functions. So this one has method for converting a result set to an RDD. So here we are just invoking that to convert a result set into the RDD, desired RDD. So now I have an RDD of located rows, and then next we will do is convert that into a vector RDD. So again, we are using the Spark mlib utils provided by Splice machine to convert an Java RDD of located rows to Java RDD of vector. The next thing is to make a call to the mlib API. So here I'm using statistics.callstats API, providing the vector RDD, and that will return me the summary in summary as object, multivariate statistical summary object. Now we have to return a result set, so which means we have to use the summary object and extract the information in the desired format. So let's look at how we do that. So we have the summary, so we first call here get column statistics. So basically let's look at how we extract data there. In get column stats, you can see that the summary object has arrays of information. So this array is like for each of the columns you specify. So summary object has a minimum array which has data for minimum values for all the columns that we have requested statistics, and then you have the array for maximum values, mean, etc. So we will take the summary object, extract data, and convert it into rows, which is what format we need to build the result set. So we loop through for each column. We get the column specific information, like for say column age, in what we saw earlier the example. So for the column age, we try to get the minimum value for age from the summary object, maximum value, and then create a row with all those details. So this is returning you a list of rows here. So from that list of rows, we are going to convert that into a result set in the wrap results. So in the wrap results, we get the list of rows, and then this one is the definition of the columns for that rows in that rows. So we use that column information to build the result set, and then finally we assign that result set to the return variable here. So that is what you are seeing there, a table rows for corresponding to the columns and the statistics of each column as listed as the column. So that is it. You have your feature report functionality here. Now let's move on and look at the movie recommender. So for that, I have a movie recommender class, and then the first thing we wanted to do is build recommender. So I have a method corresponding to it. So it is again a static method. So this is the method that gets invoked when you make a stored procedure call to build recommender. So let's look at the logic or what happens in the recommender. So we already mentioned, like, we are going to use the user rating information to learn the associations or to train the model in. So first thing we have to do is then read that user rating information. So the first few lines are just the initialization of the context, etc. So this is where I'm reading the data from user rating table into the data frame. Note here, unlike in the previous example, here I have used Spark's SQL context to read the information using the JDBC, not directly use the JDBC Java JDBC. So this has an advantage when you use data frames, and when you use the Spark context, the query is not immediately executed. The query will get executed only when it is required, when data is required. So we have lazy execution here. So if we have the data frame of user rating information, now let's convert it into the format we need. So we are going to build a Java RDD ratings. So we kind of pull out the information about the user ID here. Then we have the the movie ID, which is called as product ID in these APIs, and then the rating itself. So we'll have three pieces of information in here: the user ID, the movie ID, and the rating. Now we have our training data for the model. The next thing we will do is also get the evaluation data. Normally what people do is the same data which will be split into two portions. The first part will be used to train the model, and then the second part will be used to do evaluation. In this example, we're not doing splitting. We are just using the complete data set as training model from the user rating table, and also we will use the complete data as evaluation data as well. So what we have done is, in the evaluation, we only need to have the user ID and the movie ID, because we will be using the model to get our predictions for the ratings. So here I have a RDD of object, which is nothing but user ID, and then another item for product ID. So basically we will pull the user IDs and movie IDs from our rating RDD that we created earlier, which is for being used for training the model itself. So so once that is done, now we are ready to build the model. So in the ALS algorithm, there are three parameters that will be passed, which is rank, numeric iterations, and lambda. So those three parameters influence the model, the quality of the model. So in this case, we have kind of used some random values for these three to build the model. Normally, what you would do is, use different combinations of these and build a model, and then you will choose the best model. We will look in later how to identify which one will be a best model. Basically, how do we evaluate a model and take the best model from there. So the first thing we will do is, we are just calling the ALS API here. We are passing it the training data, which is in the ratings. Then we are passing the three parameters, rank, numeric, number of iterations, and lambda. So now we have a model built. So now let's look at how do we evaluate this model which we just built. So for that, the evaluation process would be we go use the model to predict the ratings using that model, and then we will compare those with the actual ratings which we already have in the database. So we compare these two and then calculate a mean error value. So that will give us how good the model is. So now I have here, so we already have our data set. So we do use the predict API here, and for that we are passing in the evaluation model we created earlier. So once the predictions are made, I'm just here, it is just extracting the, so it is building a RDD with the user ID, the product ID, and the predicted rating here. So we are using the model to make predictions, and we have building the Java RDD here. So now I have got my predictions. Now we have to compare that with the actuals. So let's go and extract the data for comparison. So we are building a Java RDD with two values here. One is for the actual rating and another is for the predicted rating. So for actual ratings, we are going to use the ratings Java RDD to extract the rating for that, and then we are joining that with the predictions RDD, which has the predicted value, and then we pull the, for each match of user ID and movie ID, we are getting the actual value and predicted value in this RDD here. And once we have that information, we go and calculate the mean value, which indicates the error of, which will give you some numbers to evaluate this model. So we have that MSE, which is mean square error. That is the indicator of your model. So as I mentioned earlier, you would kind of provide different combinations for rank, number of iterations, and lambda, and then calculate this MSE and choose the model with the lowest MSE. That will be your best model. In some cases, people also use different training sets, and then based on that they whatever, and then select the best model from that as well. So now we have the model. So the next step would be to save that model so we could use it later. So basically, you will be saving the model at a given path. So we are going to append that with just a timestamp, and then I'll call the model save API of in the mlib. So here I'm providing the path. This is the HDFS path where the model will get saved. So the model is getting saved in the HDFS. And finally, I'm just inserting a record into the model table with the information of the new model, the model path. basically, which can be used later on. And that's it. We are done building a model here. So now we will look at how we to use this model to get the actual recommendations. I have the get recommendations method here, which gets invoked when you call the stored procedure to get recommendations. This one requires two inputs, the user ID input and the number of recommendations desired. So let's see. The first few lines are for initialization. Now we have to load the model first. So to load the model, first thing we have to do is look at the table to get the latest model's information or the path for the latest model. So here you're just using the regular prepared statement and run the query to get the information from the database. And once I have the model path, you call them mlib APIs to load the model which is at the model specified model path. Now we call the recommend products API of the model, and we are passing in the user ID and the number here. So now I have list of recommendations as a rating objects, array of rating objects. Now we need to convert this array of rating objects into some result sets. So the next few steps are going to be converting this into a result set. And also note that this rating object will have user ID, a product ID, and a rating information. So to the end user, it's not sufficient to just provide IDs of movies. So we want to go and get the corresponding titles, movie titles at least, to display to the user. So for that, let's first create a data frame of all the data of the movie information. So I'm using here again the SQL context of Spark to create the movies data frame from the movies table in the movie length schema. Once I have that, so now here I'm collecting all the movie IDs from the recommendations. So basically I'm collecting all the recommended movie IDs. Next, I will apply this because we want only information for those movies. So I will apply that filter to this data frame to get just the list of movies that were recommended. So here we have filtered the complete movie data set, frame, and now we have a list of rows for the movies that were predicted. From these rows, we are going to convert them into result sets. For that, I'm here creating the exec rows with information of ID and the title of the movie. Once we have that list of exec rows, we create the result set, and the columns for that are specified here, which is nothing but ID and the column and the movie name. Once we create the result set, we are going to set that to the return result sets parameter. So now we have the movie recommendations for a given user. That's it. So now if you go back, so this is where we were calling each one of them. So in here we call the first one the feature report for the given table user demographics, and it got age statistics here. And then when you call the get movie recommendations, it gave you a list of movie ID and movie names. Now coming to how do we link this, I'll just go into a little more details about the store procedures itself. So we created this Java classes. So for the more details can be found in the corresponding tutorials, but I'll just give you a high level here. So we have the Java file here. So the next step I have to do is compile the Java files and create a jar. For that, we have checked in the pom.xml to use the Maven to build this. So this is basically going to build you the jar, and you know, once you have the jar, then you would have to deploy that jar, and then you will run this create stored procedures here, which will create the definition of the stored procedures in the database. So basically, you can see here you're creating the continuous feature report stored procedure, which is going to take in one input, which is the table name, and then it is mapping you to the Java class here, and indicates that it is going to return me a result set. In the case of build movie recommender, there are no inputs, and also it is not going to return any result set. It is just going to build the model. All this code is in GitHub. So if you want to build this, you can go to the GitHub, and here in the tutorial machine learning, you will find all these files. This files includes the Java classes, the XML to build the Maven using Maven, and also the data scripts and the data. And also you will find the README file with instructions on how to build that and get that to run in your environment. So the first thing is you will pull the data from the GitHub, then you will use the Maven scripts to build the jar, then you'll have to deploy that to all the region servers. Then once you have the code there, then you will create the tables using the scripts that are chucked in, and then you will import the data. For this import, you have to look at, we have the CSV files chucked into the GitHub. You may want to look at the tutorials for import to see how you can import the CSV data into the database, Splice databases. Once you have imported, then you can run the create procedure scripts, which will creating the definition of the stored procedures. Then you're ready to run the stored procedures. Thank you.